Hello, everyone. I'm Zekia. It will be my pleasure to be your host today. I am so glad that you all joined us. And today's presenter is Dr. Teddi Herring. Thank you so much, Teddi, for accepting to give this presentation. And I will start with a brief introduction about Teddi, and then we can all listen to her presentation. So Teddi joined Permafrost in 2021 as a postdoctoral fellow at the University of Ottawa under the supervision of Dr. Anthony Lekowicz. The goal of her project is to integrate existing and future electrical resistivity tomography surveys, ERT surveys, into a Canadian Permafrost electrical resistivity survey database, CPERS. The data in CPERS will be used to infer the presence, continuity, and depths of permafrost over a range of spatial scales and detect changes over time. So thank you again, Teddi, for accepting to giving this presentation. And I think the floor is yours. Yeah.
Awesome. Thanks for the nice introduction there. Awesome. Well, thanks for joining me today, everyone. I'm very excited to be sharing a little bit about the work that I'm doing. My talk is broadly about effective data sharing, but it's really told through the lens of my learnings in the process of making this database of electrical resistivity surveys. So hopefully it's a little bit about my work and I can share some of that, and maybe it will also be useful to other people who are also working on some kind of data sharing project. So if we haven't met before, hi, my name is Teddi. I got my PhD in geophysics from the U of C and joined PermafrostNet right after that. So I've been working as a postdoc in Theme 1 since April of 2021. So I'm about 3/4 of the way through my project. So I've got lots of stuff figured out and a few open questions still. And I came into this project with some expertise in near surface geophysics and specifically in electrical resistivity tomography. So this is not a talk on electrical resistivity tomography or ERT, but I thought it would be good to have like a one-slide summary just so you have the background information to know what I'm talking about in the rest of the presentation. So ERT 101, this is an image of what we would get out of an ERT survey. This is actually at one of my supervisor, Tony's monitoring sites along the Alaska Highway and just in northern British Columbia. So you'll notice there's some little black triangles along the surface of this profile. And that's where the electrodes are planted in the ground surface. We use our instrument to collect a bunch of resistance measurements, and then through some data processing magic, we end up with this beautiful cross section of an estimate of the Earth's electrical resistivity. So on the y-axis, it is elevation or depth, and then the x-axis is distance along the profile. So it's this nice cross section, and the color represents the electrical resistivity of the ground. So here I've chosen to show high resistivities in blue and low resistivities in red. You'll also notice that the color kind of fades away towards the edges and the bottom of the profile. And that's just showing where the model is a little bit less reliable the deeper that we go. So high resistivity stuff that I've shown in blue here is more likely to be frozen, and the lower resistivity stuff is more likely to be unfrozen. So I say more likely or less likely and include little asterisks here because frozen versus unfrozen isn't the only thing that governs how resistive the ground is. There's lots of other factors that go into it, like the soil or rock type, the porosity, the saturation, the salinity of the pore fluid. There's all sorts of things that affect resistivity, but all else being equal, a material tends to be much more resistive when it's frozen than if it's not. So it does help to have some kind of auxiliary information, whether it's temperatures from a borehole or something like that, to kind of validate your interpretation of what's going on in an ERT image. So in this case, frost tables were measured at this site. So those gray dots along the top of the profile indicate where a frost table was encountered with probing. So there's pretty good agreement between where a frost table was detected and where we see these high resistivity regions shown in blue. So that gives us a little bit more confidence in the interpretation. So there's ERT 101. And then zooming out a bit, now that you have the background information, I wanted to bring up the Permafrost Net objectives. So these are the stated objectives in the Permafrost Net proposal. So it says, we want to quantify, understand, and predict permafrost thaw, connect spatial scales, and prototype reliable and useful data and knowledge products. So my project is really very much focused on the third aspect, I would say. And specifically, I'm working to develop an accessible spatial database that can house electrical surveys of permafrost being conducted across Canada. So I'm hoping that by telling my story of my journey into developing a data product, it may also be helpful for people who are working on similar things in their own work. And then zooming out a bit even further, looking at international objectives. So this is an International Permafrost Association action group that I'm a part of. And their stated objective, or our stated objective, I should say, is laying the foundations for an operational international database of geoelectrical surveys on permafrost. So you may notice that there is a ton of overlap between my project and this international group. So it's really nice to see that our network objectives are also in line with what the greater global international permafrost community is up to. And it's also very fortunate for me. This IPA group was funded just around the same time that I started my postdoc. So I'm very fortunate to have the expertise of, last time I checked, it was over 50 scientists from 11 different countries. And these are all permafrost experts that are interested in geoelectrical measurements of permafrost. So very fortunate for me. And I've also been able to make some pretty significant contributions to this international effort. This is a theme you'll see throughout the presentation, is finding other groups, organizations, individuals that are working on similar things and using that to your advantage so you don't have to start everything from scratch yourself if you can. So creating a database of ERT surveys of permafrost. It might not sound too complicated, but there's a lot of things that go into it. So when I was making this presentation, I made kind of like a mind map of all the considerations that I've had to think about so far. And the point is that there's a lot of things to consider in order to make this database work and in order to make it good. So there were these themes that I saw emerging as I was making this mind map. And I'm going to talk about some of these themes throughout the rest of my presentation. So one of the big ones is meeting the needs of data contributors. There's also populating the database, actually getting data in there, meeting the needs of data users. So that's more on the how to make it accessible to people side of things. And then the last theme that kind of emerged was establishing best practices for how people should be collecting and processing their data. Now that last one, I'm going to kind of put aside for this presentation because it is a bit specific to ERT, although it is very interesting. If you have questions, I'd love to talk about it. But just to make this presentation as general as possible, I'm just going to focus on those first three themes. So the first one, meeting needs of data contributors. There's a lot of different considerations, and I'll tell you how I'm trying to meet the diverse needs of different data contributors. So the first question, really important, is understanding who would be contributing to the database and why. So the who is probably mostly engineers and scientists, probably from academia, government, industry, sort of different groups there. And the reasons why people might be contributing data are pretty diverse, actually. So this is a list that of all the reasons I could think of why people might be contributing data. I'm sure there's more. One reason would be just for the interest in advancing scientific knowledge. People might be contributing because they're interested in opening up the door to future collaboration and publications with other folks. There's also the aspect of having their data published somewhere and having that citable so they can get citations and attribution for their work. There's the aspect of having convenient standardized long-term data storage. There's also funding requirements. So this is becoming more common, and I expect will become more common in the future as well, where funding agencies may require you to archive your data in a repository somewhere and have it publicly accessible. So maybe for some people, this is ticking a box on your funding where you're saying, oh, I've uploaded my data to this repository. And then the last one I wrote down here is career legacy. And I was really thinking of my supervisor when I wrote this. So Tony retired a couple months ago, and he has, decades worth of ERT surveys of permafrost that he's collected throughout his career. So, and literally hundreds of surveys. So having these data sets available for future generations of permafrost scientists is probably a big motivation for people like Tony, who are kind of looking to leave that career legacy. So some of the ways that I've gone about trying to meet the needs of these diverse data contributors and their sort of diverse reasons for contributing data. One thing that's really important is having a data publication with a DOI attached to it. That was something we identified early on as being a necessity. So our plan is to publish data with Nordic Canada. So this would be an official data publication with a DOI attached to it that is citable. Next is ensuring the database lives on into the future. So this is a little bit trickier. So one thing that we're doing is archiving it in Nordic Canada, and that's good because it's an established repository and the data will just be archived there in perpetuity, and we can kind of update it regularly as more data comes in. But there are some open questions about maintaining the database. So I'm building a website, an interactive tool to access the data. And there are some open questions about, funding, database hosting, and even personnel for database upkeep. So PermafrostNet is a finite project, and what's going to happen to this afterwards? It's still a bit of an open question, and I expect we'll look to make partnerships with provincial or territorial governments. So there's existing databases in the Yukon and Northwest Territories. So that will be a future conversation to have, is how can we integrate this and make sure it lives on into the future. And then another super important part of meeting the needs of data contributors is having a good data policy. So that's something that's going to ensure that data contributors are invited to collaborate on, say, future publications or what have you. Make sure they're properly attributed for their work, and also that they're protected from liability. So this is, I just took a brief screen recording of the website. So this is the CPERS website that is live. You can visit it if you like. So we do have a section on here of the data policy. You'll notice right away that it says version 1.2. So this is an iterative document that's gone through some changes already. But I'll just briefly walk you through it and what I've done in the data policy that I hope will meet the needs of different data contributors. So at the top, it says that this is a policy that incorporates elements of other existing data policies from PermafrostNet, that IPA action group I mentioned a minute ago, Yukon U Research Center, and even from the open government license from the Government of Canada. So this is, I took bits and pieces from existing documents and made it suit my purposes. I have a section on the objectives, the goals of the database. I have a section on what I mean, but when I say metadata or electrical resistivity data, so that's clear for people. Data availability, so metadata or data about the data is publicly available, whereas people might not be as comfortable sharing their raw data. So maybe people are okay with sharing it, maybe people aren't okay with sharing it if maybe they have done work with a company, there's client confidentiality, something like that. And then in some cases, people may want to embargo their data, so not publish it right away, maybe wait till they're done their graduate thesis, publication, what have you. So by having flexible guidelines for data availability, I'm hoping to meet the needs of those different groups depending on when they want their data to be available. Next, there's just a brief section on data contribution and what happens when you contribute to the database. And then next, there's probably one of the most important parts is the terms of use. So this is outlining if you want to use the data, these are the things that you have to do. So one of the things you must do is contact the person who contributed the data and request permission to use it. Then it's up to you to start a discussion with the data owner to figure out an appropriate level of collaboration or attribution. So what I mean by that is maybe you're writing a paper and you want to use their data and it's a big part of your paper, then maybe co-authorship would be an appropriate thing to offer. Or maybe if it's a minor part, maybe they live in the acknowledgement section. But I really wanted to drive home the fact here that ERT data takes time, work, and funding to collect. So it's really the responsibility of the person who wants to use the data to start that conversation and make sure an agreement is reached in terms of the appropriate level of collaboration or attribution. Next, I have a short section on how you should be citing the data owners and the database itself. So just some guidelines on what that might look like. And then at the very end, I have a section on liability. So basically just saying that the data is provided as is, and we're not accepting responsibility for, you know, what I was thinking about in this section is like, what if an engineer uses a data set from the database to, like, I don't know, build a road or something like that, and something happens. So this is a section that's kind of a little bit legalese, but with the goal of protecting data contributors from any liability. So that's the data policy as it is now. If you have comments on this or would like to share any suggestions or ideas at the end of the presentation, I am all ears because this is a evolving document. So, oh, there we go. So next I'm going to talk about populating the database and some of the considerations with that. So one of the things to think about is what data to collect. What am I going to ask people to provide? So that involved creating a list of descriptive, relevant metadata fields, and also determining what ERT data should be included. I'll talk about that in a little bit more detail in the next slide. Also thinking about standardized naming conventions. And if you watch Nick Brown's seminar presentation, he talked a lot about establishing these vocabularies, standardized terminology that is really, really important for database stuff. It's not the most glamorous thing to be doing, but it is really important to have standardized terminology and variables to use. And then actually motivating people to share their data. This is another consideration. So what I've tried to do so far is focus on the value added for the data contributor. So going back to that list of reasons why they might be contributing and really kind of making that the forefront of my conversation with them, like what they're going to get out of it. And then also making the process very easy by creating clear guidelines on how to upload their data, making it as easy and streamlined as possible so it's not too difficult for them to actually share their data with me. So in terms of standardized metadata, I took a screenshot from our metadata form. So this was developed in collaboration with that IPA action group. So if you look at the top, this is at version 10 already. So it's gone through many iterations and has had many sets of eyes on it. So this is, I think, in a place where, where it's basically complete and we've figured out exactly what metadata we want people to provide. So there's a bunch of different metadata fields. Some of them are necessary and some of them are optional. So the yellow ones are the necessary ones and the gray ones are optional. So somebody would go through this Excel spreadsheet and for each of their surveys, provide some metadata about that survey. So that includes things like information about the site, information about the survey, the profile, all of these stuff that we would want to describe the data. And I want to draw your attention to one particular part of this, because then I can talk about standardized naming conventions and what we've been working on with that. So one of the things we ask people to provide is the main landform class. So what landform are they surveying? Right now, this lives as a drop-down menu in the Excel spreadsheet. So people will click on it and choose from a list of potential permafrost landforms. And one of the things that Nick Brown has been working on is standardizing this language so that there is a list of vocabulary that we've chosen to use that has like all the machine readable things that like a computer would need, and then also has like a permanent link to each of these terms and a definition and any other resources that people would need. So having this standardized language like published and saved somewhere, also where somebody could contribute by potentially suggesting new landforms and having some kind of peer review process to add new things. And I expect this will also plug into the permafrost terminology. I know that's kind of a work in progress, so that will be really nice to have as well. So here's just a short clip where you can go to the website, look at all these terms, and have a little link that has the definition and all the references that you need. So just in the efforts of standardizing this language. And then in terms of what ERT data to collect, fortunately, I'm not the first person to think about this. So I chose to use the BERT unified data format when I'm requesting data from people. So I can point them to this resource and it tells folks exactly, what their topography file should be formatted like, what ERT data they should include, what the naming conventions are, so what the different variables mean, their units. So it's really fortunate that this resource exists. I can point people in this direction, and I didn't have to do this from scratch because somebody has already come up with a very handy unified data format. And in the interest of making the data contribution process really smooth and easy, I have a section on the website where somebody can go through the little workflow of how to contribute data. So the first thing that they would do is they would click on this little icon to download the metadata form, and that downloads an Excel spreadsheet with all the metadata fields on it. They would fill it out for each of their profiles. And then depending on whether they want to contribute their raw data right away, after an embargo period, or maybe not at all, there's a little flow chart to tell them what exactly they should be sending me when they're making their data contribution. So I'm really trying to make this streamlined and foolproof and easy for people. And then at the bottom, there's a link to the data formatting guidelines. So that will just bring people to the BERT unified data format I just showed. There's a sample data upload. So if you click on that, it will bring you to a OneDrive folder where I've just made an example that includes the completed metadata form, the topography, and the ERT measurements for a couple different surveys, just so people can see what they're aiming for, like what an ideal data submission looks like. And then a little button to email their data to me. So it just pops up with my email address. So really trying to make this very simple and straightforward and easy so that people aren't put off by having it be really complicated and be a lot of work to contribute their data. And then the last thing I want to talk about is meeting the needs of data users. So again, there's lots of different considerations for this, and most of them are related to making a nice interface that people can use to explore the data. So thinking about who is going to be viewing and using the database and why. So could be anyone really, but probably community members that want to look at something within their community, engineers, scientists. And then the why, depending on why people want to use the database, I want to come up with different ways to meet those different needs. So for example, searching for data. So maybe somebody's looking for ERT data collected in a specific region or for certain site conditions. So I've made the data easily searchable. They are probably looking to assess permafrost extent or conditions and possibly even looking at changes over time. So easy data visualization is really important. So it's very easy for people to see what those resistivity data sets look like. Some folks may be using the database for more technical purposes. So maybe that's something like creating or validating models or something a little bit more technical. So my idea is to have simple and flexible data download where people can choose which things they want to download. So if somebody wants to download like the inversion parameters or the meshes or the results and really get into something technical, they can do that, but you don't have to. And then people may want to test different data processing strategies. So my plan is to have the data processing workflow published and available so people can try processing the data themselves. They can try changing different things and experimenting and trying new things. So having that open source and accessible will help meet the needs of data users. So I made this because to me, making this data visualization tool is really a balancing act between making something that's simple and straightforward. So people are just, it's easy to use, it's easy to explore the data. The plotting is just like you click a button and it plots, and maybe they might want to download an image and not much beyond that. But there's also a group of data users that are going to want something a bit more nuanced and a bit more flexible. So having the options to download all the different data types if somebody wants to really get into it and do something with kind of the more technical data. And then also having the processing code available, like I mentioned, people can go the extra mile, try new things, really sink their teeth into it if they want to. So I have one more little screen capture of the interface that I've built. So this is running on my computer, and it links into the database, pulls the data that's in there so far, and allows the user to search for things and plot them. And I'll run it. So it shows the map of surveys with all the survey locations, and you can search based on date or location or landform. So this is that drop-down menu that you saw in the metadata form. You can search by disturbance. You can search by the PI who collected the data, and you can also look for repeated surveys. So you can click that button and it will show you the time-lapse data sets. So here I'm going to search for data collected in Ross River. So it just automatically zooms to find all these data sets that meet this filtering criteria. So there's 7 of them in Ross River. If I hover over the little the dot where the survey is, I can see the metadata associated with it. So the number of surveys, when it was collected, a little bit of information about the environment there. So like the permafrost conditions, the landform, the substrate, the vegetation, et cetera, et cetera, et cetera. If I zoom in, I can click on the little dot for the survey and it plots the data. So easy peasy plotting, plots the results. Here again, high resistivity is shown in blue, so that is maybe frozen, and low resistivity shown in red, which is maybe unfrozen. And you can see I've marked the first electrode with a black dot on this plot here, which also corresponds with a black dot over here, and then a white dot for the last electrode, and also a white dot here. So you can like orient the survey to the map. So in this case, you can see that the region of the survey nearest to the lake is low resistivity. So that's potentially telling me that that might be thawed, whereas farther away from the lake might be frozen. You can see there's what appears to be a road crossing the survey, and there's also a low resistivity anomaly. So that's potentially indicating that there is some sort of surface disturbance causing thaw of the permafrost. And if I want to get a little bit more information, if I look at the bottom of the metadata here, I see there is a publication associated with this. So this is one of the metadata fields I've asked people to fill in. If there's a publication, please list it. So going to the report, I can actually look up where this data was published. I can read more about the survey and the site. And in this case, there's actually their interpreted ERT image with a bit more information. There's sort of more rich information here about, you know, where there's tall grasses and shrubs and clearings and trails and roads and stuff like that. And you can actually see the author's interpretation of what the survey looks like. So having that available is just a little bit of a bonus. Not all data sets will have publications, but it's nice to include that. So the tool I just showed you, I coded myself, I built it in Python, and that runs on my computer, and that's kind of where I'm testing it to make sure it works. And then I also have a version of that published on the website. So this is the website. You can scan the QR code or go to this link. So you can actually explore this map of surveys yourself. Right now, it just has the map and the metadata. So you can search for surveys and look at where they are, but you can't plot the data itself yet. There's a few more things I have to do before I can implement that. But this is live right now, so you can explore the data and take a look if you like. So to conclude, I will tell you some of my biggest lessons that I've learned in my 1.5 years working on this project. One is to understand the needs of data contributors and data users and use that to steer your project. Relevant standardized metadata is essential. This is what describes the data. It's what makes it searchable. It's what could make this interoperable with other databases. So having this standardized relevant metadata is so important. Leveraging expertise from other projects, organizations, and individuals. So I have really linked up with that IPA action group. I've been working with a bunch of different people. You even saw that I borrowed data policies from other existing sources. So using the expertise of other people and other projects is really helpful. And this goes to my last 2 points. There's no need to do everything by yourself, and there's no need to reinvent the wheel. Those are probably my biggest take-home messages. Leverage the expertise and information that's already out there and use that to your advantage if you are making some kind of data product. So just a quick thank you, of course, PermafrostNet, the collaborators and network partners. So there's Tony, my supervisor, Nick Brown, the PermafrostNet data scientist, has been really helpful. Fabrice Kamels at UConnU, and Greg Oldenburger and Anne-Marie LeBlanc at the Geological Survey of Canada have been working on this project with me. Also, shout out to that IPA action group I mentioned, especially Colleen, who has been such a strong collaborator with me, and we worked very closely to make the database infrastructure and make everything work. So she's been a huge help. And also the Digital Research Alliance of Canada for the computational resources, and that is where the database lives. So without them, it would not be possible. So that is the end of my talk. I'm happy if anybody has any questions to try and answer those. And also if anybody wants to have a discussion or share their ideas or feedback, I am all ears and would love to hear your comments.
Thank you so much, Teddy, for your presentation. It was great. And yeah, so if anyone, maybe we can give you a round of applause. And if anyone has any question, yeah, so we can, like, you can unmute and ask the question.
Hi, Teddi.
Hey.
Great presentation. I'm really impressed with what you've done. It looks phenomenal. And the visualization online, just fantastic.
Thank you.
Just simple questions. I think I didn't understand exactly the workflow for the integration with Nordic ND. So do people, when they submit data, do you invite them to publish at the same time on Nordic ND, or are you going to do it yourself?
Yeah, so we've deliberated this. This has not been an easy workflow to figure out, but we have a plan that I think everybody is happy with. So it will end up being one large data publication on Nordic ND. So the entire database will be one data publication. So people will send me their data, and then we'll publish it in Nordic ND and update it as people add more data. And then it will be kind of one conglomerate data publication, because if it was a bunch of individual projects, which we considered, I think that's just so much extra work to ask them to do, to go through all of those. And yeah, so that's what we landed on. So it'll be one publication by sort of the CPERS contributors, and then individual authors will be listed in the Nordic ND publication.
Awesome. Yeah, great idea. And then you update it as you go. That's a great idea.
Yeah, it took a lot of iterations to get to that. It's hard to make everybody happy, you know?
Yeah, absolutely. And make your life simple, as you mentioned.
Yes, true.
My other question is regarding the IPA action group. So what have they been doing? Like at the same time as you, have they been doing another data repository somewhere, or were you working together so that you could make something that could live on after, or how did that work?
Yeah, it's like the boundaries between the two projects are a little bit fuzzy. So they have really been instrumental in making like the metadata and the database architecture. So the actual infrastructure of the database is going to be the same for the two. So the idea being that they could share data, or maybe the Canadian database could live on with that. That is funded for 2 years, that IPA action group. So again, it's kind of a question of who's going to take care of it in the future. Although the IPA group is kind of based out of the University of Fribourg, and I know they have more long-term funding for like permafrost monitoring initiatives. So it's entirely possible that that may live on far into the future there, but it's still kind of an open question, I think.
Okay.
Yeah.
Thanks again, and great work. That's awesome. Yeah.
Thank you.
Hey, may I ask a question?
Of course.
First of all, thank you so much for the presentation, and the work is really impressive. I know that it's a lot of work, so it was perfect. Thank you for sharing your experiences with us. And I want to know that, have you, by just working with IPA, have you ever seen something same as what you did for marine ERT stuff?
Like a database for marine ERT? I have not. That doesn't mean it doesn't exist. Yeah, I haven't seen anything like that.
Okay. And may I know that how many points did you have, or you include in that database? How many, how many surveys?
Yeah, so right now we have 81 unique profiles in the database. So that is entirely from my supervisor, Tony. He's been kind of my guinea pig to make sure that the data contribution process is smooth. So I'm in the process of reaching out to other data contributors to start getting more data. But right now we have 81 unique profiles, and one of those is a time-lapse monitoring one. So we have some time-lapse data there as well.
Okay, perfect. Thank you. Thank you so much.
Thanks.
I think Daniel has a question. Yeah.
Well, it's not a question, but Teddy, I know the Alfred Wegener Institute, the Permafrost group, do have a lot of electrical resistivity tomography in marine settings and lagoonal settings as well. So you might find some interesting stuff a little bit different than terrestrial with them.
That is a great suggestion. Thank you.
Yeah. Thank you.
So Teddy, may I ask one question? Like, you have done a great job. Like, I was really impressed by the amount of work that you have done. And I wanted to know, like, what was the most challenging part of this project and the work that you were doing?
Ooh. I think all of it? No, that's not a good answer. The most challenging part. I mean, I think coming up with a clear action plan of what needed to be done, because at the beginning it was just such a big problem. I didn't even really know where to start. So figuring out what needed to be done and how to do it was honestly just figuring out what needed to be done, I think, was probably the trickiest part. Now that I'm, 3/4 of the way through, I have a great idea of what needs to happen in order to finish it. I have my little to-do list, but approaching such a big, complex problem at the beginning was really hard. So I talked to other people. There was a geophysics for agricultural purposes. They were making a database. So I talked to them and asked them, like, how did you even start? What have you learned? So getting the expertise of other people who had done similar projects was really important to getting started and figuring out a plan.
Yeah. Sure. And I think you have made it easier for people who gonna go and like, let's say, build a database. Like, I think for me, it was like you have the workflow, you have some instruction like that. Yeah, like we can use your work as a reference.
That's what I'm hoping, that maybe somebody learned something today that will help them if they're doing something similar.